Okay, the time is 11:31 sharp, so I think we are going to start, and whoever joins later, he can, of course, join us. So, good morning, everyone, and welcome to our joint webinar, Unlocking Value from Agricultural Biomass. My name is Mary Tino. I'm a project coordinator at the Bioeast Hub of Czech Republic, and I will be your moderator in today's session. So this webinar brings together two Horizon Europe projects, ManuREfinery and Rural BioRefarmeries, which are working towards a common goal, transforming agricultural biomass and side streams into viable bio-based products, while creating at the same time new opportunities for farmers, strengthening rural economies, and advancing Europe's circular bioeconomy. Although our projects focus on different feedstocks and technological pathways, we share a common vision, moving from waste management to resource valorization, and from linear systems to circular, sustainable rural value chains. So today you will hear from our experts from both projects who will present innovative approaches, practical experiences, and future opportunities in the field of agricultural biomass biorefineries. So before we begin, I want to mention a few housekeeping notes. So this webinar is being recorded, and we encourage you to submit questions or your comments throughout the sessions using the chat. We will address as many questions as possible towards the end of this webinar after the presentations. So thank you all for joining us today. And let's begin by setting the scene. First, we can see a bit the agenda. Katarina, if you can please present. Thank you. So we will start with the presentations of both projects, continue with the market details, and then it's the Q&A session and the conclusions. So it's my pleasure to introduce our first speaker, James Caffey, co-director of the Circular Bioeconomy Research Group at Munster University, and project coordinator of for Rural BioRefarmeries project. So thank you very much, James, for your participation, and the floor is yours.
Thanks, Mary. Very happy to be here, and thanks to all the organisers for organising this webinar. So we're a sister project of ManuREfinery called Rural BioRefarmeries, and we are funded under the 2023 CBEJU topic called Small-Scale Biorefining in Rural Areas. We are a 4-year project, and we started in December 2024, and we've received EU contribution of just over 7.3 million. We have 19 partners across 9 different countries, and it's very much a multidisciplinary team, including researchers, SMEs, farming organizations, industry partners, advisors, and a range of different expertise as well. So next slide, please, Mary. So just a little bit about the aim of our project. Rural BioRefarmeries aims to demonstrate a first small-scale decentralized green biorefinery model and to support its wider replication to increase local resilience, sustainability, and economic opportunities across Europe's rural grassland regions. So grass is one of the predominant agricultural feedstocks in Europe. It's about 30% of total agricultural land, which is comprised of grassland. So we're about trying to find out how grass can play a big component in supporting Europe's bioeconomy, even more so than it currently does, and how we can integrate farmers into that model also. So next slide, please. So I titled this Grass, Europe's Untapped Protein Opportunity, which might surprise some people because grass is a forage for ruminants who can convert this into milk, for example, in lots of countries. But with the bioeconomy and green biorefineries in particular, there's potential to advance the protein potential of grass even further. So in the years leading up to now, so over the last number of years, there's been work done demonstrating this base case green biorefinery process where we can extract essentially proteins that are in grass into 2 fractions. One is a cake or a dry fiber fraction, which contains part of the protein. and we can use that as a feed for cows, an alternative to silage. And we've done trials to date in a number of countries which have demonstrated that we can actually directly replace silage with this press cake, and it's a more available form of protein in grass, so we can get a higher proportionate conversion into milk and solids compared with silage. We can co-produce into our juice fraction, we call it a green juice, a additional protein along with some of the sugars and minerals, which we can separate out into a more concentrated form of protein. This time we would be looking at replacing soybean meal, which is a key ingredient, key protein concentrate ingredient in monogastric diets, and making that available from grass. So producing a higher percentage crude protein and comparable amino acid to soybean meal, and essentially replacing the soybean meal in the monogastric diets. And of course, we import a lot of soybean meal, and it has significant environmental impact importing this protein ingredient. And so we've done a number of trials to date across, again, a number of EU member states looking at replacing the soybean meal in pig diets, again, with very positive results. And this could potentially lower the CO2 footprint of our protein ingredients by about 80% compared with soy. Just click on one part there. So yeah, thank you. So this is just highlighting the fact that there's a lot of work going on behind the scenes currently to try and develop a protein strategy. So from the European Commission's point of view, we're very reliant on imported soy. So we only have about 4% of self-sufficiency of soy. So that's a key driver for developing an EU protein strategy for Europe. So there's a lot of work exploring more local proteins which we could produce in Europe to reduce our dependency on soy. And currently there's work happening in the very near future to develop and launch a protein strategy. And I suppose grass, given its volume in Europe and given the potential of these green biorefineries, holds huge potential to be a key component of that strategy. Next slide, please. So while the development of the protein side in that base case scenario is very interesting, there's also some additional challenges to implementation, which we as a project have been working together to identify and also to try and address through innovations within the rural biorefineries projects. One of the challenges we have is around seasonality of feedstocks. If we're reliant on fresh grass, which is produced for 6 to 8 months of the year, to produce this protein, it's going to reduce the opportunity to process right across the year, and that's going to impact on the economics of the green biorefinery. Next one, please. There's also a challenge around logistics and production. So in the case of grass, you're looking at a very low density feedstock. You've got a lot of water, so it's difficult to transport this over long distances. And also, when we're looking at protein extraction, typically we're looking at trying to harvest protein as quickly as possible, which places a time limitation on processing the grass in a green biorefinery scenario. And next one, please. And also one of the things we want to address is how we can use the grass better in a green biorefinery system. So currently, if you're looking at a forage and a protein concentrate as a feed, and maybe some biogas as a process for developing product for using those residual streams, all of these are relatively low value products. So while there's a lot of opportunities to improve farm resilience, it does face challenging economic payback, and that's something we want to address in the project as well to try and make it more attractive for wider implementation. Next slide, please. So within our project then, we're an innovation action, so we're not just focused on developing those solutions, but also trying to scale those solutions. So we have 3 different demonstration sites, one at Aarhus University in Viborg in Denmark, a second in Lelystad, Netherlands, which is led by Wageningen University, and finally a greenfield site which is being developed at Farm Zero C in Cork in Ireland, which is actually the first demonstration plant which will be developed and implemented in Ireland, and is being done so in an on-farm commercial farm setting. Next slide, please. So just some preliminary findings, and we are only at month 16 of our project, so these are early stage findings. But we've been working to try and identify, based on bench scale analysis of feedstock and processing at bench scale in Ireland and Denmark, what are some of the different feedstocks that we could incorporate into our production system to allow us to expand our processing to a more year-round production season and overcome that supply chain limitation. And we found very good and positive results so far, looking at a lot of different feedstocks which could be incorporated into green biorefineries. We've looked at, for example, at the processing of mid-season pasture-based feedstocks like ryegrass, multi-species swards, grass clover mixtures, which bring some environmental benefits, as well as incorporation of crops such as cover crops, which are produced later in the year, or the incorporation of silage, which would limit a bit the applications, but give us a longer processing season. And currently we're working to scale these feedstocks at NTU in Ireland and Aarhus University in Denmark to pilot and demonstration scale. Next slide, please. We've also been working with our colleagues at Aarhus University in Denmark around solutions to improve the supply chain logistics issues that I talked about. So one of these is trying to implement a decentralized green biorefinery supply chain model. We've developed a number of scenarios, and my colleague Vladislav will talk through these in more detail later on. But basically what we're trying to address on one hand is the issue around feedstock logistics. I mentioned about the inclusion of water and transporting water long distances, so how we can do some of the processing, for example, closer to the farm, but also to try and understand how we can incorporate farmers better in terms of value creation within the green biorefinery model. We've also been working to develop what we call a smart biomass supply chain tool to address some of the harvesting and logistical issues around with the processing of fresh material. And we've currently developed a supply chain module to optimize route planning between these decentralized wet fractionation units and the centralized processing facilities, and also a harvesting scheduling tool, which will be helpful to predict the availability as well as the quality of green biomass coming from these grass resources and green biomass resources. And currently we're planning some field experiments to create ground truth data to actually validate this tool. Also at Aarhus University, there's ongoing storage experiments looking at how we can preserve green juice over time to reduce the degradation of protein over different time periods, for example, by cooling the green juice to try and preserve that protein. And that's going to be something that's going to be a key development to try and develop this green biorefinery model, decentralized model. Next slide, please. Yeah, so one of the ways, and the final way that I mentioned that we're trying to address this challenge is try and improve how we're using the different products. So we're trying to develop this cascading biorefinery value chain approach. So while previously we were looking at ruminant feed, monogastric protein and biogas, we're trying to expand out some of those products. So we're still keeping those core products, but we're trying to build on additional products to try and improve the value, with some of the products potentially staying on the farm and others maybe going towards new markets to create new revenue streams. So in the case of press cake, aside from ruminant feed, we've been looking at the inclusion of some of those fibers into food biodegradable packaging materials. In the case of our protein concentrate, we've been looking not just at the production of monogastric protein, but also the co-production of potentially human-grade protein as ingredients in human food products. And in the case of our anaerobic digestion of our residual brown juice, aside from biogas and biofertilizer production, we've also been looking at the extraction of volatile fatty acids, which could be used in a range of different applications, from animal health to food applications like flavors and packaging applications as well. Next slide, please. So just some preliminary findings, and again, early stage, how these products are developing so far. So in the case of the Rubisco-rich protein fractions produced alongside the green feed grade proteins, this is showing promising early potential through our colleagues in Aarhus University. They have already been producing protein of over 70% crude protein, and we're hoping we can improve that further as the project progresses. In the case of the brown juice conversion into volatile fatty acids, such as butyric acid, we've been having very good results looking at these fatty acids through our colleagues in the University of Galway and PUT, Poznan University of Technology, and demonstrating high yields so far in terms of butyric acid production. And also our colleagues in Wageningen University have been working with our industry partners in Paperfoam, a company in the Netherlands, to look and test several different prototype packaging materials, which include these press cake fibers as an ingredient. And so the next steps will be to bring additional partners involved in this validation of these products and to work on further improving these products and scaling these with our research and industry partners. Next slide, please. Yeah, so I think this is just my last slide, and it's just we have a lot of other aspects of the project where we look at analysis of all these value chains, and Vladislav will talk a little bit about this. But during the next phases of the project, we're going to be working to try and scale up these value chains and to validate them with our industry partners to analyze the potential of these economically, environmentally, socially, and also we're going to put a big focus on replication also. So first of all, there's a QR code which is going to link you to our project website, and it's going to allow you to join a network which we're going to be establishing, which is going to contain a lot of information and training materials regarding our Rural BioRefarmeries project and the development of these green biorefinery technologies. We have a Danish demonstration day, which is going to be happening on the 9th and 10th of September, which people are free to register, and we'd love people to join that. We'll be holding a second demonstration day in Ireland next year. And just the slide on the screen shows our focus on replication. So we have, aside from our 3 demonstration regions, Ireland, Denmark and Netherlands, we also have replication regions in Bulgaria, Italy and Poland, but also I've highlighted those in green, but also the regions in yellow just highlight all of the countries across Europe where over 15% of the total land areas comprised of grassland. So there's huge potential for replicability of grass-based biorefinery systems right across Europe. So we'd really love for people who are across Europe to get in touch with us, who are involved in farming, who see potential for this, to get in touch with the project and join our network so we can transfer and work with you in terms of some of the activities we're doing and some of the knowledge we're generating. Next slide, please. And yeah, I just want to say thanks to all of our partners. I'm presenting the results, but the results have been generated by 19 partners, and we have a great team of people who are involved in this. So thanks to all of the partners for all their amazing work. And I think that's it from my side, Mary. Thank you.
Okay, so thank you very much, James, for that insightful presentation. And we've just seen how grasslands, often considered underutilized, can become a key source of sustainable protein and bio-based products. And now we will turn to another important agricultural side stream, livestock manure. So it's my pleasure to introduce Raúl Muñoz from the University of Valladolid, who will present the ManuREfinery project. Raúl will show how manure can be transformed into viable bio-based feed ingredients and fertilizers through a modular small-scale biorefinery approach. Raúl, please go ahead.
Perfect. Thank you very much. I realize I should change the picture. I think the picture is maybe 15 years younger than I am. Okay, so I'm going to introduce the main objectives and value chains and demo sites of the ManuREfinery project. It's a project that aims at deploying smart, modular, mobile, and sustainable small-scale decentralized biorefineries in order to convert livestock manure, I mean, any type of livestock manure from cow manure, chicken manure, and pig manure, and the gas emission from farms into bio-based feed, like microbial protein from different sources, caproic acid, protein-enriched grass, biofertilizers like nitrate, ammonium bicarbonate, and phosphorus-rich acids, and bioingredients. Okay, so our concept in this topic exhibit a high scalability and replicability potential, deploying 3 valorization lines and supporting 7 value chains. Next. Okay, so this is the ManuREfinery concept. We are dealing and valorizing the 3 main sources of pollution in farms. We have a gas valorization line aiming at extracting the ammonia from gaseous emissions and convert it into nitrate, sodium or potassium nitrate in value chain 1. Then any kind of manure can be anaerobically digested using thermophilic digestion. The biogas produced is converted into a novel high mass transfer, high pressure bioreactor into microbial protein. Then the liquid fraction of the digestate is separated. It's liquid and solid fraction. The liquid fraction is used as a source of ammonia. We can extract the ammonia and convert it into ammonium bicarbonate into value chain 3. The liquid, the water that has been exhausted in ammonium still contains some nitrogen and phosphorus. This water can be used to fertirrigate, to produce grass. Grass is pretreated, fermented to produce caproic acid into value chains 4. And also the remaining grass still contains protein that will be used also to produce another source of protein in value chains 5. And also the the solid fraction of the anaerobic digestate is dry, gasified, converted into syngas. Syngas is converted into acetic acid in high mass transfer reactors, and the acetic acid converted into microbial protein in value chain 6. And then the remaining fraction from dry manure gasification is used to produce other type of fertilizer in value chains 7. Okay, next. Okay, I'm gonna go through quickly through the objective. The first objective is modeling, designing, and engineering of all the technologies that will support the 7 value chains. A specific objective 2 will demonstrate and validate ManuREfinery technologies, basically optimizing and validating at demo scale in 4 farms across Europe this efficient, modular, and small scale biorefinery concept, targeting 3 different type of farms: cow farms, pig farms, and chicken farms. In a specific objective 3, we will evaluate the quality and validate the bioingredients produced. Okay, so bioingredients, we have sodium or potassium nitrate, ammonium bicarbonate, 2 types of microbial protein, the grass protein, the caproic acid, and then phosphorus and potassium-rich acids. Next. Specific objective 4, demonstrate the economic viability and also the techno-economic, social, and environmental performance of our biorefinery. Specific objective 5, ensure adaptability and replicability of ManuREfinery solution across Europe. Specific objective 6, assess marketability of ManuREfinery solutions. And finally, dissemination and communication of the main project results. Okay, next. I'm gonna go into detail into the partners. We have partners across all Europe. ITA is the coordinator of the project. ENCO, who will present today, is in charge of the business model. KISS, who is supporting the demo site in a cow farm. Wascore Energy is integrating the excess of energy in the biorefinery. Agrobal Farm is supporting the demo site in Spain. Tetricon in charge of ammonia extraction, conversion into ammonium bicarbonate, and also phosphorus recovery. University of Zaragoza performing the hybrid modeling of the process. BioEconomy is also supporting in the dissemination and communication activities. Paris and Denver are 2 Romanian partners, chicken farms and pig farm, hosting the ammonia valorization line. Bio2 CHP is supporting the gasification of dry digestate. University for Economic Forecasting is supporting the Romanian farms. Our Institute of Sustainable Processes is supporting several of the technologies. CISPRO is constructing several of the high performance bioreactor. Colsen doing anaerobic digestion and biogas conversion into microbial proteins. Telecnis supporting techno-economic analysis and also ingredient validation. Hydrom doing the extraction of caproic acid. University of Firenze also doing the LCA and social LCA. Fertinagro validating the ingredients. Ghent University developing the grass fermentation into caproic acid. UECV also supporting the dissemination and engagement activities. Wallen Green similar tasks. UNEIVO is also working on engagement of the several partners or several stakeholders. Okay, next. I'm gonna go quickly through the main valorization line. The gas valorization line will be implemented in 2 demo sites in Romania. Interprot farm, which is a big farm with 32,500 sow, boars and piglets and winners. Demo site 2 in Romania is a chicken farm in Denver who will host the biotrickling filter for ammonia conversion. Okay, next slide shows the main concept. Okay, the gas emissions from farms will be extracted, conducted to a biotrickling filter, high advanced biotrickling filter, where ammonia will be dissolved, nitrified, and converted into sodium nitrate or ammonium nitrate, which will be validated by Fertin. Next slide shows the pilot plan. It's a 1 cubic meter biotrickling filter constructed by CISPRO, who will be shipped to Romania in the coming week. Next slide is the liquid valorization line, who will be hosted by Agrobal farm in Spain. Okay, in a farm like 1 hour from Valladolid. Next one. This is the most complex valorization line. Sorry, it's liquid valorization line. I made a mistake. So the liquid manure is anaerobically digested under thermophilic conditions by Colsen. The biogas is fermented into a novel configuration of gas fermenter. Biogas can be either used to produce energy in the process or also microbial protein using an EFSA approved methanotrophic bacteria. The ingredient, the microbial protein, will be validated by AgroCesa, who is actually Agrobal farm. Now they changed name. The solid fraction of the digestate will be treated in the solid valorization line, but the liquid will be extracted in terms of ammonia, converted into ammonium bicarbonate, and also the phosphorus will be extracted via electrocoagulation. So we will produce ammonium bicarbonate and also phosphorus, and the liquid, remaining liquid, will be used to produce grass. Grass juice will be extracted, fermented to produce caproic acid as a diet supplement, who will be also validated by Agrobal farm, and also the protein from grass will be also validated by AgroCesa. Next slide shows the pilot plant that have been already shipped from Colsen to Spain. On the left side, you have the thermophilic anaerobic digestion plant. It's a 20 cubic meter thermophilic digester. In the middle, we have the high mass transfer biogas fermenter to produce microbial protein from biogas, and also a 3D representation of the ammonium bicarbonate and phosphorus recovery unit. And on the right side, we have the demo caproic acid fermenter to produce caproic acid from grass, which is under construction. Okay. Next slide is the 4th demo site, who will be hosted by KIS in Slovenia. It's a dairy farm with 80 heads of large cows, dairy cows, producing over 1,000 tons of cow manure per year. Next slide. The cow manure will be dried, will be gasified, the syngas can be used to produce electricity, but will be also integrated by Wascore, or the syngas can be introduced in a syngas fermenter to produce acetic acid, and the acetic acid will be separated from biomass. Acetic acid will be fermented using Cupriavidus necator, which is also a EFSA-approved microorganisms, to produce microbial protein validated by Agrocesa. And the ash from the gasifier will be also analyzed and validated by Fertilizer. And the next one, but it's already the end of the presentation, is the 3D scheme of the plant that are under construction by Bio2CHP and also by the U-loop reactor constructed by CISPRO. Okay, and that's all from my side. This is just the work package structure. Okay, work package 1 is like more framework methodology and drivers. The key technical package are work package 2 on technical development and digitalization, and implementation, deployment, and valorization line. And then we have transversal activities assessing the sustainability, the market, dissemination activity, and the coordination of the project. Okay, thank you very much.
So thank you, Raul, for that very comprehensive overview. So we've just seen how manure, traditionally seen as a waste stream, can be converted into multiple valuable products, from microbial protein to fertilizers, through scalable and mobile biorefinery systems. We now return again to the rural biorefarmeries perspective, this time focusing more on the economic aspect. So I would like to invite Vladislav Popov, presenting on behalf of Peter Borisov. Vladislav will explore how these biorefinery models translate into business opportunities. So Vladislav, the floor is yours.
Thank you, Mary. Nice to meet you. I hope that you can hear me.
Yes, clear.
Yeah, I want to be very quick, and I would like to present you very quickly some of the preliminary findings that we have so far. But just to come back and then see the technical objectives, as we have done for the ManuREfinery project. First of all, to develop a small biomass supply chain, as James mentioned, to optimize small-scale and decentralized green biorefinery system, because, in brackets, we have done last year a survey among 33 farmers, grass farmers in Denmark and Ireland. And basically, most of them, like 50 to 60% of them, are willing to explore the decentralized green biorefinery system. So we have to work on this aspect more than the centralized. I'll come back to this later. Then support farms in developing new revenue streams by collaborating with industry partners. It is also a task that we need to develop. Foster more sustainable practices among grassland farmers. Again, this survey shows that most of them, more than 50% of them, are willing to cooperate. But there are some differences, of course, between Denmark and Ireland, but most of them mentioned that one of the conditions is to cooperate, to collaborate, in order to cut the costs, scale up and replicate the proposed circular biorefinery models across the EU, but also through a new rural green biorefinery network, replication network. James mentioned that we are also targeting farmers in not only in the Netherlands and Italy, but also in Poland and Bulgaria, being Central and Eastern European countries. Next, please. You see the picture that James was explaining, that we're trying also to not to stop with fresh cake, green juice, and brown juice, but also some products that will have a market value. And by the way, for instance, there are again, and there will be differences between farmers, because some of them, and most of them, are working now for silage, but most of them are willing to consider also producing these products and to sell them on the market because of the higher added value. Next, please. We tried to focus now at the end of last year and this year on the base case scenario, which is the centralized green biorefinery, to calculate the costs and benefits, profit and losses of this centralized green biorefinery. But as mentioned, as James mentioned, there are some advantages and disadvantages. I'll come up to this on the next slide. But biomass is collected from multiple farms, transported to a large processing facility, converting clover grass into tree products. Byproducts are returned to farms for reuse. That's the basic model. Leaf protein, fiber, and brown juice. Next, please. You see the technology and process in very simple terms: harvest, fractionation, protein, and drying. We try to calculate how much we can receive by this process and what processing capacity is needed. Next, please. And on the next slide, you see advantages and challenges of this centralized model. The advantages being a large-scale processing, improve efficiency, easier quality control at single factory, better energy utilization per kilogram protein, and reduced need for multiple processing units. But the transport on a long distance is expensive. The transport delays. Also, we have to consider processing bottlenecks if excess material arrives. Coordination between farmers and facilities are required. And seasonal growth variation, James mentioned. Next, please. But what we tried to come up was this triple layered business model, which means not to analyze the economic benefits at the economic layer, value proposition, costs, revenues, capex and opex, and profitability indicators, but also to make sure that we are also considering and analyzing the social layer in terms of governance, rural employment, stakeholder coordination, etc., and the environmental layer, material and energy flows, biomass cascading, etc., etc. Next, please. And at the economic layer, everything is pretty clear. We based our calculations, basic calculations and draft calculations on figures that are coming from Denmark. You can see the draft calculations in our business model, centralized business model. Next, please. But when we come to the social layers and environmental layers, why we stress the importance of these two layers? Because they concern communities and governance, basically rural value creation. What value we create for the rural communities, local employment, income diversification, regional economic stimulation, etc., etc. Workforce, governance complexity, multi-actor coordination, farmers, operators, biogas plants, etc., etc., with transparent contracts and fair value sharing, and the social risk, overload, workload pressure, barriers for smaller farmers, potential unique value distribution. By the way, based on the surveys, interviews that we have done with the farmers, they mentioned several factors when they express their willingness to develop, for instance, decentralized models. This is basically access to technology, financial support in terms of subsidies, market development, market opportunities, political and regulatory support. This is also very important for them. So therefore, we are making sure that we are integrating social and environmental concerns. Next, please. You see the environmental layer. We are making sure that the circularity and environmental hotspots are included. And basically, what we're trying to say with making all these calculations for the centralized model is to show to the farmers. James mentioned that the first workshop with farmers and local stakeholders in Denmark will be in the beginning of September. So we'll present these figures for centralized model, and then we'll discuss them, advantages, disadvantages, opportunities for decentralized model, both centralized and decentralized. But we have to make sure that we also pay attention to the value of the nutrient recycling, what these grasses, also legumes, are bringing to the soil health and soil nutrients, which is usually not taken into account in business models. But we have to take this into account in evaluating money, because as you know, There are subsidies even now until next year in this programming period for farmers that are growing protein crops in the rotation. So this is very important when we grow alfalfa or white clover or red clover, to enrich and to show, to evaluate what is the benefit and value for the soil nutrients. Next, please. And you see that the last slide, fact sheets about Danish business case, all these figures that we came up now with the draft of the business model. But you see that in the bottom, key strength, multi-product cascading valorization, soil substitution. Also, we have to mention the carbon sequestration, nutrient recycling, but key risk, capex intensity, drying energy demand, biomass transport logistic, which is very important for the farmers, and the strategic role as benchmark scenario for decentralized and hybrid rural biorefarmeries models. Thank you. Thank you, Madam.
Okay, so thank you. Thank you very much, Vladislav. That was a really insightful look at how these technologies translate into real-world business models, including, of course, the importance of cascading value chains, multiple revenue streams, and the balance between economic, environmental, and social impacts. And we now move on to our final presentation, focusing on market opportunities and exploitation. I would like to invite Giuseppe Salvio from Enco Engineering and Consulting, representing the ManuREfinery project. So Giuseppe will present the market perspective and discuss how these innovations can be brought closer to real-world deployment. Giuseppe, please go ahead.
Yes, thank you. Thank you. I'm going to share my screen in a second.
We already have the presentation,
okay.
so it's already on.
Perfect. So yeah, thank you for the invitation. It's Giuseppe Salvio here, responsible of the exploitation business unit here in Encon in ManuREfinery, responsible as well of the overall exploitation activities and as well the business models. Let's say that I structure my presentation focusing as well a bit on the business model concept, since this leads also to possible market opportunities that we might have thanks to the implementation of the technological and technical activities of the project. So I would like to start also connecting from the previous presentation we had before, what makes the biorefinery business model difficult in a bit. So we need to consider different factors, since let's say we do not have, let's say, a single product at the end of the value chain to be sold, but we also have feedstock processes, we also have risks and technology we developed. So we need to consider that we have facing an heterogeneous feedstock. So we have a variable quality and seasonality and logistic all in the reshape process economics. We have a multi output logic. So here the value of what we are presenting on the market, it depends on balancing the high value system with also the nutrient recovery and byproducts. We faced different markets. So the fertilizer market, the feed market, the chemicals. Also, we need to deal with all that concern the rules on the waste we generate. And all of these together also with the last factor, which is the local deployment, because it doesn't exist, let's say, a one real business model, but we need to adapt it based on the context that we have. All these mixed together will make us understand what kind of direction we need to take also under the market perspective. So all these four factors, just to say that business model that we are creating in, I'm talking about, of course, ManuREfinery project, but this is valid also in general, must be modular, and we need to adapt it based on the context and not on, let's say, a fixed one. In the next slide, we can see what has been already, let's say, anticipated a little bit by Raul before. So what is the ManuREfinery business model? We are now at the stage during this first phase of the project. We they don't have yet, we do not have yet all the capital costs and operational costs related to each of our demo sites in Romania, Spain, and Slovenia. This will be done in the next phase of the project. So this is just what we also plan to do in this sense, in order to have, let's say, the same quality of data that our previous colleague shows before for the Danish pilot, because this is very important then, because it's easy, easy to, let's say, demonstrate the technical feasibility, but what is most important also is the economical feasibility. So if we have something that is good under the scientific point of view, we should find a way on optimize it in order to have also revenues and break-even point as soon as possible in order to cover the costs. The core marketable solution, as you can see, is not only one, it's not only the recovered products, it's also the bio-ingredient, and it's also the technology in the ManuREfinery case, which is mobile and modular, so that we can sell in units or in a unique combination. If we proceed going into the specific, but I'll be very quick on this, what has been already said. We have, let's say, 3 different valorization lines which are connecting to 2 different market ecosystems. And as you can see, we have as output biofertilizer, we have feeds, we have fertilizer, we have probiotic, and of course also the technology for the units. What kind of possible business models are we or we will test? If we go on the next slides, we can see that we have like different kind of models, different kind of revenues also from all of them. So we can do the equipment sale or lease. So the technology provider selling or lease the modules to the farms or the hubs, or the cooperative or hub model. In this case, the farm networks are sharing the capital cost at the beginning and then the recovered output streams, or even a service model. So here in this case, an operator is managing mobile units, and it is paid by the throughput of a service fee, or a hybrid value sharing where the revenues from the product sales and avoided costs and environmental value it's shared. Those are, let's say, the hypotheses today on the table, but as I said before, it will be very important to then score them against the capital costs and operational costs, so the ownership also facts that we need to investigate, the logistic, the regulatory route, which is also an important aspect, and of course the farmer acceptance, because without them we cannot do basically anything. Then we are creating value not only for the payer, of course, which is the beneficiary. And we, if we go on the next slides, we can see that we are creating values for different actors in the value chain. So for the livestock farms, in this case, they reduce the manure burden, they recover nutrients, and they create new income streams. We are creating value also for the fertilizer actors, so accessing the nitrogen, potassium inputs, local sourcing, and sustainability claims. We are creating values as well for the feed actors with through alternative protein, functional ingredients, and supply chain resilience, but also for the whole rural ecosystem under the environmental point of view, with lower pollution pressure, with local jobs, and with also innovation in the widening regions. So we need to be able, when then we are going more into the concrete and doing the implementation, in monetizing both on direct product revenues, but also the indirect benefits that are not always only economic, as you also see from this, let's say, recap. What we need then to validate also We need to validate in order to create a structured business plan and understanding the market opportunity. What are, of course, the revenue streams and what are the cost drivers. So in the next slides, there is just an exemplificative one where the revenue streams might be the recovered ingredients, the technology or the service fee, the avoided disposal, so we do not have the transportation cost, and sustainability and compliance value. With cost drivers, those are of course driven by the capital cost of modules, the energy and consumables, all the operation and maintenance, and quality, compliance, and logistic. Then we need to, as I said before, then move from what is the environmental value to the real business value. So we can be very competitive, of course, if we have a business value. So we need to consider four different aspects. So the technical aspects, where we need to consider technical factors such as the yield, the uptime, the modularity, the product quality. We need to consider the economic aspects. So what I said before, capital and operational cost, logistic, price, payback time, and all these values that let us understand when a solution is, let's say, convenient under also the economical point of view, the environmental factors, and the adoption. What we are doing now in this sense in the project, in ManuREfinery project, if we go, let's say, not the next one, but 2 slides in advance, we are now in month, let's say, 18. So we just concluded our reporting period, and we have, let's say, the baseline with the first market analysis we have conducted. This will put the basis in order to study together with a technical partner the best business model to be tested in the solution. We are then in close contact with who is dealing the techno-economic assessment, which is Università di Firenze in this case, in the case of ManuREfinery. So in a European project, in order to create a valuable business model and business plan, it's something that you do not do, let's say, alone, because you need the inputs and the collaboration with the who is doing the environmental and economical studies, and from the technical partners as well, in order to see what could be the best revenues they expect to collect. Then we need to be able to put everything together, offer different scenarios, because we cannot consider only one scenario. We need to be optimistic on one side, but also pessimistic on the other side, because we need to consider everything that can happen. And we hope to deliver the first scenarios and perhaps present it in the next webinar we might have together, when we will have more, let's say, concrete data in 1 year, 1.5 years, more or less. Then we need to do the refinement, because this will be a preliminary version. And at the end of the project, we are going to have, let's say, the final business model and plan that our partners can implement. And of course, this needs to also follow the after the project, because we need to, let's say, do not waste what we have done in project. If we move, but I already said that, so maybe we can skip into the next one. How we think to do that during our project, also to collect inputs from all the partner. We are going to do a first business opportunity assessment during the coming month, where we are going to evaluate where for each demo site, which one is the, let's say, strong parameter, and which one is the weakest parameters, if we consider as parameters the market, the technology, the IP, the formation of the team. So based on these parameters, we are going to do an assessment exercise to see at what kind of status we are now. Then we are going to work on understanding clearly what the customer wants, because this is important to define what we need to offer, or to evaluate if what we offer is sufficient to address all the needs of the customers. This will be done considering each different customer segments. So for each customer segments, we are going to understand how we can create value for them. Also, then the transposition of all the finding into the lean canvas to present and to have clear under one table the business model, and of course structure the commercialization plan for each of the demo of our project. So as a key takeaways to conclude this presentation, so the modeling, as you also already know, it starts before the final validation, of course. There is a lot of work to be done in this sense to understand what kind of model we would like to present and which one is, let's say, more convenient. In the case of ManuREfinery, should be modeled, at least this is the finding that we have today, as a modular solution. The fact that the incomes are diversified and there is nutrient recovery, pollution reduction is a strong point. And what we need to do then in the next future is to convert the market baseline that we had at the beginning of the project, or maybe better, in the first phase of the project, into financial scenarios. So this is all from my side. Thank you.
Okay, thank you, Giuseppe, very much for your presentation and for presenting the market perspective and how these innovations can be brought closer to real-world deployment. Thank you to all our speakers for those presentations. So we've seen today how different agricultural side streams, from grasslands to manure, can be transformed into valuable products through innovative and scalable biorefinery approaches. And we will now move on into, for the last minutes that are left, into the Q&A session. Feel free to continue submitting your questions. We already have one question on the chat, and it's for both projects. What are some of the commercial applications of these proposed bio-based products? Could you give a few examples? Whoever wants from the speakers, of course, can answer.
I could start. So I mentioned already that we produce this, what we call a leaf protein concentrate. We can use that as direct replacement for soybean meal as kind of an obvious starting point. Some of the other products we're assessing during the project to try and validate these in, with our research partners, our industry partners. But I suppose one of the uses we're looking at in terms of fatty acid development, and particularly butyric acid, will be some of our farmers who are involved in the pig farming side of the project. Caribou piggeries currently use butyric acid, but produced synthetically as an additive in pig diets to improve pig intestinal health. And so we would be looking at replacing that with our bio-based butyric acid, which is being produced from our brown juice residual fraction as an alternative bio-based version. In terms of the fatty acids, we're also going to be working with UCD, Trinity College, Tarbury Group. Tarbury have a flavors division, so we're going to be looking at different fatty acids and their potential use in high-value flavor applications. And then we're looking at this potentially food-grade protein source as well. And so we'll be initially looking at that, comparing it against products like whey protein in collaboration with Tarbury, who are our dairy sector partner, who's a lot of experience in protein shakes, protein powders, protein bars. So looking at the white protein or the Rubisco fraction in potentially some of those applications, but then as we find out more about the products, we'll be comparing it back against kind of different benchmark products that are out there. It could be egg, it could be soy, so different types of protein sources.
Thank you, James. And on behalf of ManuREfinery,
Yes,
Raul, maybe? Or
here we have
Giuseppe,
the.
yes?
Yeah, Raul, please.
Whoever
Could you please repeat the question, because there was a colleague that
Yes,
entered,
of course.
and I
Uh,
forget to give some exams.
The
and I
question
didn't
is,
Yeah.
it's okay. What are some of the commercial applications of these proposed bio-based products? Could you give a few examples? You can both, of course, offer your perspective.
Now, protein produced will be used as an ingredient for manufacturing of feed for animals. I mean, the nitrate salts, the phosphorus recover, and also the ammonium bicarbonate as ingredient for biofertilizers. I mean, there will be energy that can be integrated to power the farms if it's not used for other application like protein production or basically protein production. And and that's also the protein from the caproic acid. It's used as a probiotic for animal nutrition also. So everything was designed to be circular and to produce ingredients that can be used on farm.
Giuseppe, would you like to add something?
No, nothing to add. It's quite exhaustive, Raul.
And I have another question from one member of our audience. So to all speakers, what do you believe would be the most critical positive or negative factor when moving from the pilot projects to a large-scale implementation of the solutions you presented from both projects?
And I can start. I mean, from a technology point of view, I mean, the scale up should not be a problem. Probably interactions with the farmers and the operation of the technologies is critical, because we are not talking about skilled operators. Their business is the farms. They know they have to deal with the pollution. So actually explaining how the system works, the importance of operating the technology, or if this will be externalized and there will be people operating and maintaining the process. I think it's more about the implementation rather than the scale up of the technologies in our particular case.
And on behalf of Rural BioRefarmeries, would you like to comment on that?
Yes, I can say very similar things that Raul said. I mean, this preliminary survey and work with the farmers, interested farmers in Ireland and Denmark, showed that they mentioned the financial support, financial incentives, task incentives, training, access to technology, all this kind of stuff. It's a complex. It is a complex of factors. There are different factors that have to work together. Also, one thing that I mentioned several times to my colleagues is that we are approaching a moment for the next programming period, the next CAP. And as you know, there are subsidies for so-called adding value to agricultural products. It's still continuing interventions in forms of interventions in the rural development plans. So we have to make sure that we show these figures to the policymakers somehow and try to influence them to include also the social and environmental components, social and environmental benefits, monetize them in terms of money, as Giuseppe mentioned, and make sure that the final cost benefit analysis in order to convince farmers to undertake these models include social and environmental benefits. If these two elements are not included, and if we're talking only in economic terms, I'm a bit reluctant, and I have my doubts that the farmers even if they cooperate, they will be willing to undertake and try to establish these business models that we're offering them. I don't know, maybe James have another opinion, but at least my first impressions are like this.
Yeah, I support what Vladislav said. I would just add on some of the technical challenges moving from pilot projects to large scale. Like a big one for us will be managing the logistics of supply, dealing with fresh feedstocks. When you're getting to that large scale, well, even when we talk about large scale, we're still, I guess there's a limit to the scale we're talking about, and that's one of our focuses, is to try and reduce the scale. But going from pilot to, let's say, commercial scale, might be a better term. It's still going to be a lot of logistical optimization that's required to manage the feedstock supply, to ensure we're getting high quality biomass, and that's what we're working to test during the project. And obviously that's also going to influence the quality of products that we produce as well. And with those products, there are some regulatory barriers that will need to be overcome in terms of getting some of the products to market, particularly those which we are kind of targeting coming to the human food chain, which will be another challenge from the commercial side.
Thank you so much, everyone. And I would like to ask my colleague Katarina to stop sharing the presentation. And I would ask for a favor for everyone to open their camera so we can take a photo for this joint webinar. Whoever wants to open their camera, thank you in advance. Okay, so I'm waiting for more cameras to open and to see your smiles. All right, so just give me a second.
Excuse me, please, my camera doesn't work.
Oh, it's okay, Carmen, no worries. And we are fine. Okay, now, as we are reaching towards the end of today's webinar, I would like to thank all of our speakers for their valuable contributions, for sharing insights from both projects, ManuREfinery and Rural BioRefarmeries. So today's discussion clearly showed that unlocking value from agricultural biomass is not just a technical challenge, but also an economic opportunity for rural areas. Thank you as well to our audience for your engagement and for the questions. We hope you found this session insightful. We look forward to continuing the conversation in future events. I would also like to thank my colleague Katerina, Betty, and the girls from Australo, Alex and Julia. So have a great day and thank you for joining us.